Hello everyone, today we're looking at our second video involving rough incline planes and pulley systems. This will effectively be a continuation from the last video where we worked out the tension and acceleration of the system and we looked at the forces acting on the pulley. Now the purpose of this video is to tackle the two-step SUVAT style questions and gain an understanding of that. So what I've got here is our 5 kg block and our 2 kg block that are connected on by a light inextensible string, where the 5 kg block is hanging in freely and the 2 kg block is on a rough inclined plane. And as per usual for this question, we do need to label our forces onto the diagram. Now I've already put on the weight and the tension, the 5g weight over here, the 2g weight here, the tension here and here acting towards the pulley. That's all the forces we need for this 5 kg block. But the 2 kg block also has its reaction force coming out of the slope perpendicular to it. And because it's a rough surface, there is also friction involved. So we do need to have our value of friction coming down the slope over here. And because this system is going to be moving, friction is at its maximum value of mu r. The last thing we need to do with regard to this diagram is to make sure we resolve our weight components, resolve the forces both parallel and perpendicular to the surface. So we drop our perpendicular from here with r and we make it so that it levels out on the other side over here, and the angle of 30 degrees is over here. We're just going to label the forces on the diagram. So the perpendicular component is 2g cos 30 because that is the adjacent, and that leaves over here 2g sine 30. And that is our full diagram. Now the question first asks us to work out the tension and acceleration. Now we did do this in the previous video, so I'm just going to pull up the method which we did last time and quickly give you a quick overview. We had over here, we first did F equals ma on the 5 kg block. We then did F equals ma on the 2 kg block acting up the slope. You always do it in the direction of motion. We then said that R is equal to 2g cos 30 because the forces perpendicular to the slope are in equilibrium. And then we did simultaneous equations with our two equations over here, the F equals ma on the 5 kg and the F equals ma on the 2 kg block. That enabled us to cancel out our tensions by adding the two equations, and it gave us an acceleration of 5.115 meters per second squared. Now I'm actually going to write that over here because that is very key to the next part of this question. Following that, we worked out the value of tension by substituting our acceleration back in to give us 5g minus t equals to 5a. 5g minus 25.58 is tension, and tension gave us a value of 23.42 newtons. So that was our process we looked at for the last question. So at this point now, we are going to move on to the next part of this question, which says find how far the 2 kg block travels before coming to rest. Now, if we look at this scenario, the 5 kg block is going to accelerate downwards and it's going to hit the ground after traveling 1.2 meters. That means the 2 kg block is going to move up the slope 1.2 meters and it's going to accelerate up the slope for 1.2 meters. So it's talking about coming to rest. Now, you can only come to rest when this tension is no longer in play, and that occurs as soon as the 5 kg block hits the ground. Because the reason this is coming up the slope is because the 5 kg block is coming down and the string is taut. The moment the 5 kg block hits the ground, the tension disappears in the string. There's no more tension involved in this situation. And this leads to a change in acceleration, which then leads to a change in the SUVAT, which is why this is a two-step SUVAT. Now these two steps take place in the sense that there's one step where we are looking at the scenario before the 5 kg block hits the ground. So I'm going to put that up here, say before hitting ground, we have our SUVAT, S-U-V-A-T, and then we also have another SUVAT for after it hits the ground. So I'm just going to put it over here, after. And again, we have another SUVAT over here, S-U-V-A-T. Now, before the 5 kg block hits the ground, it's going to travel 1.2 meters, which means the 2 kg block is also going to travel 1.2 meters. So we can put over here, this is 1.2. The initial velocity is 0, and the acceleration is 5.115. Now, with regard to a two-step SUVAT question, the moment this hits the ground, this has gained speed. And it's gained the same amount of speed as the 2 kg block because it's traveled the same distance, it's had the same acceleration. Now, the moment that this hits the ground, the tension disappears, meaning that there's a new scenario. But what the key thing to note from a two-step SUVAT, it means that whatever the speed was or the velocity was when this finished hitting the ground becomes the initial speed over here. And that's very, very key with these two-step SUVAT questions, is that the speed will change from the final velocity of scenario 1 to the initial velocity of scenario 2. Now, because it's asking about the 2 kg block coming to rest, we know that this is going to be a velocity of 0. We can work out the acceleration, which we'll do in a second, and we know we're going to work out the value of the distance for this question. We don't need to work out time, and we don't have any values of time, so actually we're going to ignore these in particular. So the first thing we need to do is to work out the final velocity, which we can do from over here. And for this, if we use v squared equals u squared plus 2as, we can work out the value of v squared, which is 0 squared plus 2 times 5.115 times by 1.2, which is equal to, on your calculators, 12.276. So v squared is equal to 12.276. And if we square root that answer, you get 3.504. So v is equal to 3.504 meters per second. Actually, for that, I'm going to write that in over here to show that we work this out afterwards. 3.504, 3.504. Now, if there's no pull left on this block, it means that this is going to be slowing down. It means it's going to be slowing down due to the friction and due to the weight. So actually what I do in these scenarios is I draw what is happening in this situation. I draw the diagram again without the tension. So after the 5 kg block hits the ground, the 2 kg block only has friction acting on it, so mu r, because it's still moving, and it has the 2 kg block, or the 2g, acting downwards, meaning we have our two components over here, where this was our 2g cos 30, and this is our 2g sine 30. And what this means is now, if we look at F equals ma on this particle, it's still moving up the slope. So if we apply F equals ma after the particles hit the ground, so this is F equals ma on the 2 kg up the slope, and this is after, which is why it's in green, we can write minus mu r minus 2g sine 30 is equal to 2a. Now mu and r haven't changed. The reaction force here is still equal to 2g cos 30, and mu is still equal to 0.2. So if we substitute those values into that equation, we get minus 0.2 times by minus 2 times 9.8 cos 30 minus 2 times 9.8 sine 30, and then divided by 2 gives us an answer of minus minus 6.597. So the acceleration is now equal to minus 6.597. And now that is our acceleration for this part. So I'm actually going to write this in over here again in a different color, showing we worked it out later. Minus 6.597 meters per second squared. And it is negative because the particle is slowing down. It started at 3.504. It does need to slow down to 0. And so for this, we now have our value of u, v, and a. Once again, we can use v squared equals u squared plus 2as to work out this final answer, which I will do over here on the right hand side. So v squared equals u squared plus 2as. V squared is equal to 0 squared. U squared is 3.504 squared plus 2 times by minus 6.597s. Now, if I'm trying to work this out, I simply need to rearrange this and take the 2 times minus 6.597s to the left-hand side. That gives me a value of 13.19. So we're going to write over here 13.19s is equal to 3.504 squared. Well, actually, if we look back over here, if we square this value, we get 12.276. So this is 12.276. And therefore, to finish off, we just need to divide the 12.276 by the 13.19. And if we do that, we get a value of 0.93 meters. So this is going to be equal to 0.93 meters. So our final distance that has been traveled over here is 0.93. Now the question said, find how far the 2 kg block travels before coming to rest. Well, from the beginning, it didn't say find how far it travels after the 5 kg block hits the ground. It's saying how far does it travel in total before coming to rest. So we actually just need to add up the 1.2 and 0.93 for this. So very, very simply, last step here is to say the total distance is 1.2 plus 0.93, which gives a value of 2.13 meters. And that's the full question. So let's just quickly review. We first worked out the tension and acceleration via our steps of F equals ma and simultaneous equations. We then came to the 2-step SUVAT. Now we said you need to consider the motion before the 5 kg block hits the ground, where the tension is still present, and then look at the situation after the 5 kg block hits the ground, where there is no longer any tension. So when we look at this, or when we consider this, we can say we can use we can use SUVAT over here to work out the final velocity, which becomes the initial velocity over here, and then we definitely need to work out the new acceleration for the SUVAT afterwards. This is the point, probably the thing which most people forget to do, to work out the new acceleration, and then from that again use your value of SUVAT to work out the final distance. I hope that's made sense. If it hasn't, please leave a comment below or please message me directly. Take care. Thank you very much.